Well, I've told you a few times already that I'm not going to get any more machines. And now I've got 2 more. And I've got them kind of on indefinite loan. Now I tried to pay him something for them, but he keeps saying, I'm sorry, I don't speak English. So they're mine to use for as long as he wants me to have them. I'll drop in a bit of video of us collecting them on his trailer, and then we'll take a look. So this video will just be having a look at what I've got. Just a bit of messing about, really. Well, we're out collecting some machinery with Tony again. These have been in storage at a friend's house, and it's time to pick them up. So they were at Tony's house, in his shed, some of it anyway, and the shed had to go because he needed to build a garage for his car. Rover 75, is that right, Tony? Rover 75, which is what, 75 years old, did you say?
1948.
1948. So anyway, the car got priority, so these got displaced and now they're being collected. So his friend's at his friend's house, but the friend needs the space back anyway. That's the story. So a couple of these are coming to my house. We're going to put them in the Haxby Shed annex building. So you might recognise this as a Clarkson tool and cutter grinder Mark 1. It's a bit scruffy, but everything's here. There's a table sits on there, which is over there, I'll show you in a moment. And we'll look at the bits that have come with it. It's 3-phase, it's got an inverter already fitted, so pretty much it's ready to go. So looking down into the pillar, the isolator's on this side here, and the power comes up under and into the isolator. So that's mains feed to the inverter. That's motor side. This is control side. That's a bit loose, Tony, I'll have to fix that. But he's wired in the original pillar switches on the control side of the inverter, so that's right, that's good. The work light's got a bit bent. One of these joints needs straightening out, and it's got a bespoke guard on the grinding wheel, but it's okay. It's got a low-vo light, so at one time that would have been 3-phase fed for a 50-volt light, but now it's 240 volts fed, and Tony's put in a LED bulb. So I'll probably stick with that. I mean, this is a great big box, and I could make it simple with an LED driver, but I don't know. So we've got the belt guard, the flat belt, quite a few of these wheels. That, I'm not sure what that's for yet. A massive end mill that I will never use because it won't fit my mill. The centres, and that's about it really. Some freebie steel, bit of flat bar. We took the motor off. I'll just swing round. It's back here. We took this motor off just to save weight while we were transporting it, because it was a bit awkward. Somebody's put a chuck on here, look. Is that focusing? But it's just into one of the collets, look, so we'll figure this out. Now, Tony's also given me an ER32 holder, which he'd bought to put into this. And, well, I'll take a look at that in time as well. So there's a lot of work ahead of me with this. But I think to start with, it's just going to be a fair bit of research to understand how these are used, really. A few videos to watch. Now to this thing, Denford 2600 Pro CNC flatbed router, A3 size. It'll cut, obviously, wood and plastics, but also should cut aluminium and maybe brass. It won't do steel. Computer controlled, computers come with it, so I'm going to set it up, see if I can get it to do something. The software's a bit tricky from what I could see. I did see it running, but the software's not very intuitive. It looks like you've got to do the process flow in your mind. You use various bits of software and go from one to the other. But we'll see if I can get it to wake up. 150 kilos, this thing. So what's that, £330. It's a pretty solid piece of equipment. So it's, maybe it's not quite professional standard, but it's well up there in terms of its, you know, construction and performance, I think. This is a nice little design studio setup, but not so good in the winter when it's freezing in here. So I suppose I would do designs in the house and then bring out a memory stick. This PC is Windows 7. I do have Ethernet on this side, but I may not connect it just for security reasons. With it only being Windows 7, it might be best left standalone. Now this router is November 2009, and I know it's hardly been used. Almost new, really, in terms of usage, that is. Well, the monitor's alive. It's booting. Oh, of course, these days you have to connect the monitor to the PC, don't you? Haha. Oh, it comes alive. There's an interlock on this front here. I could just heard it go then, so you can't open this unless the power's on. This is the software that came with it. And when I open it up, look, I haven't seen one of those in a long time. But it comes with a CD as well. And the PC's got a CD reader on it now, look. Yeah, definitely more research needed. So like I said, this video is just a bit of discovery, that's all. These are the two programs, QuickCam 2D Design and Virtual Reality CNC Milling. Right, dismiss that. Look for something that's already there. So open, clock. Okay, so I think that's what you would route out, that shape. And then generate, creates a file, and then I think that drives the router. So to create Haxby Shed, first thing is open the 2D editor. So 2D as in it creates 2D shapes like a sign, not 3D shapes. Haxby Shed. When you're happy with it, you press this button by my finger here, and that creates the output. So it calculates the tool paths, so the movement of the tool over the work, and it creates the G-code, and the router runs from G-code. Now some of the trickiness in this particular software, there's a tool tip has just popped up there. I'll zoom in to show you. So tool tip, and it says create toolpaths and G-code from the current design. But then we've got VR here, virtual reality. Now the second program is a kind of modeler, so you can run simulations and you can do a virtual reality simulation, and then you can send that to the router. I keep saying router, I should say router for this. So now I've moved on to the VR CNC milling software. Now they call it VR software because you can do a virtual reality simulation, as they call it. And this is the G-code file that I created from my script in the 2D editor. So to simulate, I can go for a 2D stroke 3D simulation here. Now it's going to look a bit small for you, but I can't get round it because I want to show you the whole screen. So off we go. It's now writing Haxby Shed, and you can see the commands here scrolling through. Okay, so that's a basic 3D simulation. If I go to VR, so I can close that, go to VR, it now opens up and you can see the router here. Now I've got to start a process of setting offsets. Well, first off, I need to home the machine. Now it's homing the machine in VR, so this, if it had been over here, it would have homed here. The spindle would have moved over to the back right corner. If I go to auto and checking that I've got the right units, so the units are metric, if I set the units to imperial and the program's written in metric, the whole thing will overshoot and fail. Let's say it that way. So stop, rewind, go, and we should see this now starting to simulate and I haven't quite got the hang of this yet, but I should just about be able to scroll this. I just can't get it to work just yet. I haven't learnt enough. There you are, and you can look down on here and see it working and scrolling through. And you're just making sure that it doesn't exceed the machine's limits. Now you can see it's come from the home position into this corner, and that corner is what's called the work offset. Now you can put your work down anywhere on this table, so you've got to tell the machine where the work offset is, otherwise it'll just be working in free space instead of on your work, or it'll be misaligned. And that's quite tricky to do, I think, to set that offset. So here's my work, and the router is in the home position at the moment, which is 0, 0, 0. I've got to move that to here, to this corner, bottom left, because that's the reference position for the work. And then we'll get a number, and the numbers that I see here I can put into the offset. So using the keyboard, still obviously in VR mode, I can come across here to get into this corner. Now when you hit a limit, you see these arrows. I can come down, probably just come through the table. And then when I find my position, I can take these numbers, put them into the offset. Now I need to do that on the real machine, because obviously I'm just doing it in VR there. And it's to prove that when I've got it set up, the spindle doesn't go off the limits. And it wouldn't break the machine, I suppose, unless you got too much Z and you went straight into the table. That would happen if you weren't careful. So we need to switch this now into machine mode and drive the machine to find the offset position. So we come out of VR mode, we go into machine mode. So it's now connected to the machine, and I've got to home the machine first of all. Okay, you can hear it going back to the home position, and you can see it's going to come back to 0, 0, 0. So now the software knows where the spindle is, and it's calibrated across the table X, Y, Z. Yeah, so now we need to go to jog, and we're going to jog across to the 0 position for the work. I can speed this up, I think. There we go. We've got the override to speed up a bit. Now if these covers open, this only works at, I don't know, less than half speed, just for safety. And we're going to put our cutting bit right over the corner. Now this isn't going to work very well just now, because I've not got it set up right. But what will happen when I'm happy that I'm on the bottom left corner of the work, I read off the numbers and I put that into my offset. So by jogging across, I've found the work offset. So yeah, I can change it, but let's just say it's that, right? So that is the bottom left corner of the work. Now those numbers, that's not accurate actually, but never mind. Those numbers need to go into the offset. So here we've got the offset screen. Yeah. So I know I've programmed in previously -552, -389, that's the corner of my work, and then -64. Now you need to be careful with the Z if you like. I've set a design depth of 5mm, but I didn't want it that deep, so by setting the offset plane a bit higher, the cut is a bit less. But it's to the millimetre, so you need to be careful about setting these. So I've set left front corner 1/4 is what I've called that offset. But you've then got tooling data, because you have a tool offset and you have a work offset. So if you're a big fat tool, you might want it, you know, to start from a different point or something, if you were working with the tool edge rather than the tool center. So you've got a tool library, so these are all the dimensions in the tool library. Now this machine doesn't have a tool changer, but if it did, right, so you need to get these right. The spindle motor takes ER20 collets. I couldn't find that anywhere in the spec. I had to measure it up to figure it out. And the router bits often come on a quarter shank, regardless of the size that you buy. And they're quite expensive, maybe £80 for 4 or 5 of these. Carboid. I'll have a think about that. I will need to get some more, but I don't want to rush into buying them. Just in trying to figure all this out, I've put a sticker on for the maximum extent of travel. So minus 600x, minus 400y. So that's the maximum position for the bed travel. Well, after quite a few hours, and on the second attempt, this, but on the first attempt, this, and it's all about setting the work offset. We'll take it back to home and then we'll take the side panel off and look at the controller. It was making a horrible noise at first when I was doing that, and then I had to use some silicone spray on the tracks and on the ball screws. It's all very solid. This is where I drop it on my toes, isn't it? Well, it's very nicely put together. And there's the controller. Controller board, I suppose. Power supply, relays and fuses. Filter. Logic controllers, I suppose, XYZ, I don't know, just guessing now. Yeah, so it's a nice bit of kit actually. The hardware of it is really good. So that's basically how this thing works. Could be very useful, but it's taken me 3 or 4 hours to get to this point, trying to figure it all out. Particularly those offsets are quite difficult, and the software's not very intuitive. But I had a look at Fusion 360, and that has a model for this machine. Now that might be just produce the G-code and the tool tracking, routing, whatever that's called. I don't know. Whether I could use Fusion 360 to drive this directly, I mean it's a standard G-code language model, so maybe. I've got to look into that. And I've upgraded this to the latest software for those 2 programs. Now they do make, Denford do offer a 3D editor, but it's about £450, so what's that, $600 plus US. I don't think I'll be doing that. I'll be looking for some other way of doing 3D work, and it might be Fusion 360 because they offer you a free license for non-commercial work. So I've got the hang of the router basically. I think my next step is going to understand what I can do with Fusion 360 and what programs I can use to generate toolpaths, G-code, and perhaps look more seriously at upgrading that PC to Windows 10. The milling software was crashing from time to time. I have reinstalled it. I don't know if Windows 10 would help anyway. But I think basically the box itself and all the hardware is really good. Now for this, tool and cutter grinder, this is a bit more straightforward. I'm going to clean it up, just wash it down basically, put it together. I don't want to have another great big project, although I've said that before, haven't I? I'll just basically get it working and experiment with it a bit. So mostly just cleaning it up. Anyway, that's giving you an overview of my 2 new machines. Thanks for watching.